Hello, let's look at practice test 3. Okay, last practice test here. If we look at number 1, remember this is just on the 3 assignments that we've had since test 2. Okay, so 3.1, 3.3, and then that last assignment with logs and exponentials. Okay, so number 1, we've got a quadratic function question. Okay, is the graph of f of x equals 7 times x minus 2 squared minus 5 is a parabola that opens, so we want to know if it opens up or down. Okay, so since this, our leading term, that a term, is positive, and that means our parabola is going to open upward. Okay, that's that first part. With the vertex at, and remember we have, this is h, this is k, h, k. So we have to do negative h, right? So we'll have 2 is our x-coordinate, then k is just, we leave it alone, so negative 5. Okay, so x minus h plus k. Okay, and then if that's true, if that's a point on our graph, then f of 2 is negative 5. Right, that's what the point 2, negative 5 being on our graph means, is that f of 2 equals negative 5. Okay, so that's the vertex. So remember, we've got a parabola that opens upward. So the vertex, remember, is either going to be a minimum or a maximum. Since this one opens upward, this is going to be the minimum value of our function. And number 2, sorry, it's kind of spread out on here. So we get a graph, quadratic function, negative x squared plus 8x minus 7. And this is one of the long ones where we've got several things to find. So first it says find the vertex. So since we have a graph, we can do that on the graph here. So our vertex is at 1, 2, 3, 4 to the right. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 up. I'm going to label those so we remember. Our vertex is at 4, 9. There's our vertex. Then we want the x-intercepts. Okay. So where we cross the x-axis, we'll get x-intercept there and there. Okay, so we've got one at 1. And we also have one at 5, 6. This will be 7. So our x-intercepts happen at, our smaller one is the point 1, 0. Then our larger one is the point 7, 0. So there are our x-intercepts. Okay. Then it asks for the y-intercept. We can't see it on the graph, so what we have to do is we have to find f of 0. So that just means we're going to plug in 0 of x, for x. Okay. So up here, if we plug in 0 for x, we'll get negative 0 squared plus 8 times 0 minus 7. And remember what happens everywhere we have an x goes away. So our y-intercept is at negative 7. So our answer box down here, our y-intercept is at 0x, and then our y is negative 7. Okay, got a little bit more on the next slide. So it says find the maximum or minimum. Which one are we going to have? Well, this opens downward. So this is going to be a maximum. And the maximum value of our function, and the maximum happens at x equals 4, but the maximum value of our function is 9. Okay, so we're going to have a maximum value of 9. Okay. And then another way of thinking about that, that's as far up as our graph goes, right? We go up to 9. So the domain, remember on these, the domain for quadratic functions is always going to be negative infinity to infinity. Don't have to think too hard about that. That's okay to memorize. And then the range, we said the biggest our function gets is 9. Okay, so how small can it get? Well, these things go down forever. So the smallest our function can be, smallest our y values can be, or negative infinity, and then we go all the way up to 9. We said that was our maximum. Okay, so there's our ring. Okay. Number 3 is similar, but it doesn't give us a graph. Okay, remember, I'm not going to ask you to express these in standard form. You don't have to worry about that. If you want to express it in standard form, that's fine. Okay, but I'm not going to make you express it in standard form. Okay, so the first one says find the vertex. So remember, for our vertex, we've got negative b over 2a that we do, and then we'll plug that number into our function. So here our b is 6, so we'll have negative 6 over 2 times a, which is 1. So the x-coordinate of our vertex is negative 3. Okay. So now we'll plug negative 3 in for x. So if we do negative 3 squared plus 6 times negative 3 minus 3, what do we get there? So this is 9 minus 18 minus 3. Okay, so that's negative 9 minus 3, so negative 12. And so there's our vertex, negative 3, negative 12. Now, what about our x-intercepts? If we don't have a graph, the way we find our x-intercepts is we take our function and we set it equal to 0 and solve for x. X-intercepts, that means y is going to be 0, equal to 0. And we solve here. Okay, let's look at this one. Okay, if we look, we try to factor. Factors a negative 3 that give us 6. Those don't exist, so we're going to have to go off to the side over here and do some quadratic formula. We're going to do negative b. Here's quadratic formula. B plus or minus the square root of b squared minus 4ac 2a. So here we're going to have negative 6 plus or minus the square root of 6 squared minus 4 times 1 is negative 3 all over 2 times 1, so all over 2. Let's see what we get there, and then we'll come back. 6 plus or minus. See, what do we get under here? So 6 squared is 36. Plus 12. Because negative 4 times negative 3 is positive 12, so this is going to be 48. 2, so we're not going to get a nice clean number here. Let's see, does it tell us we can use decimal? Oops, sorry. Does it tell us we can use decimal places? Okay, so I'll try not to give you one this ugly. Okay, let's see. Square root of 48. That is 4. 2 square root of 12. Hang on, let's see. 16 times 3, so square root of 16 would be 4. 3. Okay, over 2. So this thing's ugly. We get negative 3 plus 2 root 3 divided by 2. Plus or minus, sorry. So we'll have, I'll try not to give you one this ugly. So we'll have negative 3 minus 2 root 3 0, and then negative 3 plus 2 root 3, 0. Right. Sorry, these are so ugly. Those are our x-intercepts. That does happen sometimes. Okay, our y-intercept. Remember what we're going to do? We're going to plug in 0 for x. So we'll have 0 squared plus 6 times 0. Both of those will go away, right? And then minus 3. Our y-intercept is at minus 3. Have 0 plus 3. And then it says sketch a graph, so that's not kind of messed up here, but let's see our. We got negative 3, negative 12. Negative 3, we go down to negative 12. And then this thing opened. Sorry, my program's been a little glitchy here. Scrolled way too far. And then we know our y-intercept's at 0, negative 3, so we'll use that as our other point. So then we can go over 2 this way. Raffle. Something like that. X-intercepts would usually be good, but here they're going to be some ugly number, so. Find the domain and range. Okay, the domain's easy. Negative infinity to infinity. The range, right, the smallest we're going to be is negative 12. And we are going to include negative 12. Then we go to infinity. Okay, that makes me think of something that I forgot to use the square bracket on the last one of those we did. Here on the last one, this should be a square bracket because we do go all the way up to 9. Sorry about that. I think we are done with this one now. Oh, yes. Okay. Alright, so now we just have one that says find the maximum or minimum. So if you want to, you can rewrite this in the order you may be more comfortable with looking at it. Switch the order of the terms back around so we get the squared term in front. And anytime you see a quadratic and it says find the minimum or maximum, then we're going to look at the vertex. So here we'll do negative b over 2a. So we'll do 6, that's negative b, over 2a, so that's 2 times negative 1. So 6 divided by negative 2, negative 3, that's our x coordinate. That's not what we want, that's where the minimum or maximum occurs, but we actually want the minimum or maximum, so now we're going to take negative 3 and plug this in. So f of negative 3 give us 5 minus 6 times negative 3 minus negative 3 squared. What's this give us? This gives us 5 plus 18 and then minus 9. 5 plus 9 gives us 14. Okay, and then is this a maximum, minimum? Well, our leading coefficient out here is negative, so this opens downward. So that means this is a maximum value. Okay, it's the maximum we can get out of our function. Okay, number 5 is the same type of problem. We do negative b over 2a, we'll get negative 12 over 2 times 2. So negative 12 over 4. And just by coincidence, that gives us negative 3. So then we're going to plug that in. Do f of negative 3. 2 times negative 3 squared plus 12 times negative 3 minus 5. I'm going to break out my calculator on this one. So negative 3 squared is 9. So 2 times 9 plus 12 times negative 3 minus 5 gives us negative 23. And since our leading coefficient was positive, that means our parabola opens upward. This is a minimum value. Okay. Number 6. Even though it's a word problem, it's the same thing. Okay? The same thing, because this is a quadratic function and it's asking us for a maximum. So all we have to do is look at the vertex. If you write this thing in the standard order we're used to looking at, then it's negative 0.4 x squared plus 80x. So for the x coordinate of our vertex, it's going to be negative 80, negative b, over 2 times negative 0.4. That's negative 80 divided by negative 0.8. So this is going to be 100. Okay. So that's our x coordinate. What's x? X is the units. So we're going to have 100 units. And then now we want to know r of 100. R of 100, that's going to be in dollars. Okay, so we're going to take and plug in 100. So we'll have 80 times 100 minus 0.4 times 100 squared. And I'm just going to do it in my calculator. So 80 times 100 minus 0.4 times 100 squared, 4,000. So if we make 100 of whatever it is that we're making, then we will have a maximum revenue of $4,000. Okay, it's just another vertex problem. Number 7. Got some polynomial division to do here. And I will give you, on these, I will make sure that I give you ones that you can do either synthetic or long division. I won't force you into one method. You can do either way. So here, I'm dividing by x minus 3. I'm going to do synthetic. And then I would put a positive 3 out here. Then I'm going to look at my coefficients and make sure I'm not missing any. So I've got x squared, x, and a no x. So none are missing. I don't have to put any placeholders. So I will have a 3 minus 10 minus 4. Bring down my 3. 3 times 3 is 9. Gives me minus 1 when we subtract or add, however you want to think about that. And then negative 1 times 3 is negative 3. Negative 4 minus 3 gives me negative 7. And we started with x squared, so that means this coefficient is going to be on x. We decrease by 1 every time we do synthetic. So I will have 3x minus 1 plus negative 7 over x minus 3. Okay. Number 8. Same thing. I'll do a different color just because I can. Okay, so it was plus 4, so I'm going to put a negative 4 out front. Check to see if I need any placeholders. I don't, because I have x to the third, x squared, x, no x. So none are missing. So my coefficients up here will be 3, 9, negative 6, negative 1. Bring down my 3. 3 times negative 4 is negative 12. Gives me negative 3. Negative 3 times negative 4 is positive 12. Gives me positive 6. 6 times negative 4 is negative 24. I end up with a remainder of negative 25. My problem had x cubed, so now I'm going to start with x squared. So I'm going to have 3x squared minus 3x plus 6 plus my remainder of negative 25 over x plus 4. Okay. All right, one more. And this one gives us a box for the quotient and for the remainder. So, okay. Again here, I had -4, so I'm going to start with +4. Okay, if I look at, see if I'm missing any terms, yes I am on this one. I will need some 0 placeholders because I have 1x cubed, but then I have 0 x squareds, 0 x's, and then I have -64. So I have to have 2 placeholders. Bring my 1 down. 1 times 4 is 4. Gives me 4. 4 times 4 is 16. 16. 16 times 4 is 64. -64 plus 64 gives me a remainder of 0. Started with x cubed, so I will have x squared plus 4x plus 16 with a remainder of 0. Okay.